Okay, it's 4:30. I'm going to go ahead and get started. Welcome to creating financial applications with spreadsheet macros. No, I'm just kidding. It's a basic Kubernetes debugging kit, and I mean a couple of things by that, and you'll see what I mean as we go on. I put a few of the usual suspects up there, but we're going to see some other things as well. Who am I? Why are we here? Why are we sitting in this room? Why are you bothering to listen to me? And what is the ultimate fate that we're all bound for? Well, probably the ultimate fate we're all bound for is to get back on our command lines when we get out of here and go back home. This is some basic info about me. I've been in IT for about close to 25 years now. I've worked for Capital One, CoreOS, Red Hat. Shout to anybody in the room who's worked for those places before. I started with Kubernetes in early 2015, so I'm at least as new as most of you are. And I've been working with it full-time since late 2015 when I joined CoreOS. I currently work at Mesosphere. We are hiring. Come see me. Come to our booth. Pronouns, he and him. Blood type, caffeine positive. That's probably the most important thing on this slide. And I have some contact info there, and that great big ugly QR code is that same contact info plus the slide URL. So I'm going to leave this up for a second if anybody wants to grab that, because I apologize in advance. Some of the command line text on these slides is a little bit hard to read from way in the back of the room because they're intended to be read and kind of referred to rather than just be pretty slides. So you might want to grab that QR code now so you can pull those slides up and follow along, or pull them up later and catch up either way. I'll give that for a few more seconds. And these are posted on the Sched, by the way, so if you want, you can just go there and download them later. Why traditional low-level tools still matter in this world where we have all these nifty new cloud-native tools that do all kinds of nifty new cloud-native things. Sometimes your new tools don't go in place smoothly. Sometimes they break. That's just the way things are. Other reasons they might matter in your day-to-day operations, they're already there. You already know how to use them. You just have to pick them up and put them to work. And you'll probably get further with tools that you're experienced with, all other things being equal, than something that you're trying to learn how to use for the first time in an emergency. I don't know about anybody else, but I have been the guy in the data center, and somebody says, oh, just run the debug tool that we wrote for that. And I'm like, okay, how? What do I need to do? I tried to run it, it didn't work. What arguments do I need? So we're going to go through, this is probably the meat of the talk. This is the basic tools that we're going to go over, and then we're going to see some applications of those tools. And we'll talk about some of the ways that you can get those tools in where you need them to be in. Everybody's seen CubeControl, I hope. If you haven't, well, that's why you're here, right? So you can get familiar with that kind of thing. Some of the lesser-known KubeControl things that you can do a KubeControl attach. You can watch the standard output of a container in real time. If you read the documentation, it will say that you can actually send signals to the process. I've never gotten that to work, and I was talking to one of the Kubernetes maintainers yesterday at Contributor Summit, and I said, and he was one of the CLI people, and I said, hey, what about this? I've never been able to get this to work. And he went, oh yeah, I never have either. So I didn't feel so bad anymore. But I mean, basically, so what we're looking at here is I just created a container, and all it does is it continuously writes random data to standard out and also tease it to a file. So speaking of things going to a file, if you read the 12-factor manifesto, it says, do not log to a file. Log to standard out and let the environment pick it up. Guess what a lot of applications do anyway? So if you want to get that log file, you have to break into the container and grab it somehow. Well, one of the easy ways to do it is KubeControl CP. You can just copy a file out of the container. You can put one into the container. It'll actually let you do some more interesting things, but the basic usage is just this. It looks a lot like copying to an NFS share, if you've ever done that before. I'm sure some of you have. You can find out more about what's going on than you ever wanted to know by throwing a couple of V arguments at it. You can just give it a kubectl get nodes, gives you the nice, neat little table. If we say kubectl v-v6 get nodes, we get a little more output. If we say kubectl-v99 get nodes, we get a lot more output. I actually clipped this off because it's just pages and pages and pages of config loaded from cache and config loaded from this file and that file. And then it gets down to this here, and this is the part that I really wanted to show you is it actually shows you right here. This is the curl command that you could run that would do the same thing that it just did. And then it tells you here, this is the response that it got. These are the response headers. This is the response body. It's basically every single piece of data that you could have except for the raw TCP dump packet capture from this particular transaction. Now, in reality, there aren't 99 separate levels of verbosity. I think it stops around 8 or 9. But V99 is just kind of the community convention for give me everything you got. There's a couple things you can do to get help on the fly. If you're trying to remember things, when might you be trying to remember things that you can't just go look them up? I wonder when that might be. Almost like if you were being put to some sort of test. Maybe some sort of certification test. So, you know, it might be helpful if you could have your utilities explain things to you. Of course, if you're in the data center and you're trying to read things on your phone, this might be helpful there too, just on the off chance. You can say, explain CRD, and it gives you a description of a CRD, a custom resource definition, and it gives you all the fields and a brief description of the fields. And if you say, well, wait a minute, I want more detail on that field, you can say, explain CRD.spec, and it tells you all about all the subfields in the spec of a CRD. You can keep going as far down as you want. You can actually go all the way down to where it just says, hey, that's a string, this is the string, I have no more for you. There's a couple of links down there. There are some other things. kubectl completion. You can actually have kubecontrol output shell completion logic for your shell if you're using bash or ZSH. Auth can I. Literally just you say kubecontrol auth can I create pod, and it says yes or it says no. And then API resources gives you a summary of all the API resources. There aren't really arguments or options for that. It's basically just a quick reference table of all the things you can do on that server, though. So if you have multiple clusters with multiple API versions, you can actually ask it, what's valid on this cluster? And it'll tell you. Output control -o YAML gives you a nice manifest. It actually gives you some extra stuff. You probably have never created a YAML manifest with things like generation or creation timestamp. Probably, well, you might have created some with annotations. And then it has a status field. But the point is that you get options for how you are given the description of the workload that you're looking at. You can do JSON, and it'll give you it in JSON format. And we're actually going to be looking a lot at JSON very, very shortly. Oh, and also look at JSON path support as well. That allows you to do some pre-filtering of that JSON right there from your kubecontrol command. You can give it a filter expression, and it'll just give you back the bits of JSON that you're actually interested in. So then we turn to curl. We saw earlier that kubecontrol will tell us how to curl a transaction to duplicate the functionality of the kubecontrol utility. Well, one of the things you have to do to actually do that is you have to throw a header in there if you're using bearer tokens or something to say, this is my authorization token. And that's how you do it. You just say -- header. It's not rocket science. There are some other things that you'll need to potentially do with curl, and we'll get to those in a minute. Some of the things you have to pay attention to are what kind of request are you making with curl? If you're just getting info on a resource, or if you're watching or listing resources, that's a get. You don't need to specify a method with that. That's the default method. Then if you're doing other things, you need to use a different submission method. Post creates a resource. Patch, merge updates a resource. You give it a patch blob or manifest, and it merges that into the pod or the whatever resource it is you're updating. Same thing with put and delete. They have their place. I gave you a quick example of a get here. This is just get me a pod list. And this is a scrolling thing, so you can see it goes all the way down to the bottom, and then I cut it off because you get the point at that point. And then I put links down here. There are actual detailed guides in the API reference for write operations and read operations on pods and everything else too. For a lot of these things, if you go in there and you look at the API spec for it and you click on it in the table to the left, It'll give you write operations, read operations, delete operations, you know, yada, yada, yada. Watching for changes. So this is, you could take this, you can watch for changes to resources. This is basically the core of every custom resource controller you've ever seen. They put a watch on something, and then as data comes through, they act on it. And if the watch terminates for some reason, the connection's broken or something, they pick up where they left off, and they start the watch again until you terminate that resource controller. So this is how you do it. You just say, whatever it was, if you look back at what we got before, this curl command here is the same as this curl command here, except I added this at the end of it. So you can watch pretty much any API endpoint. There's also a watch part of the API. It seems like the convention is to use $watch equals true at the end of the endpoint rather than using the watch API specifically. Use whichever one works for you. I haven't found any cases where they're different at all. The other thing I want to call your attention to here is we have this bit here. So it tells us a type because we're looking at pods. It tells us that, or no, excuse me, we're looking at nodes here. We were looking at pods before. Pods in the cluster I did this on don't change much. I threw an example pod in there, and so it said, hey, there is a pod, so it says added, because then your controller would go, oh, there's a pod I need to watch it, do something with. Nodes are a little more active. Nodes actually check in every few seconds, and they constantly update themselves. So what you get in this 3-node cluster is, right when you do the watch, you get the info on the nodes at their current state as an added type. Then as they start updating, you start getting these modified types down here because now they're updating their status every 5, 10 seconds, whatever the interval is. And so you can actually watch what's going on in your cluster nodes. If you filter that information down, you can see it goes all the way off to the right here, but you know. Feeding results to other things. So what good does it do to just sit there with a curl spitting info on your command line? Not much, but what you can do is you can take this curl command here and you can have it, you can run a bash while read, if anybody's ever used read line or other read operations in here. You can have it reading everything that comes through. All of these added and modified events that are coming through here can be read and acted upon. And in this case, I'm piping them to this whole long JQ thing here. This is all a JQ pipeline. We'll talk more about JQ pipelines in a little bit. What I'm doing is I'm filtering out some info about that node, and then I'm putting it into a format I want, and this is what I get down at the bottom. It actually says, here's a node. This is the node name. That's all I'm interested in that case. There's another thing you can do with bash. It's called a coproc. Depending on who you talk to, they'll say it's either the greatest thing since sliced bread or you should never use it at all. But if you want to do that and investigate whether that's the thing for you, this is a very simple coproc that does basically the same thing as this. So OpenSSL. Everybody here loves OpenSSL, right? It's the most user-friendly tool in your arsenal, right? Hands up, user-friendly? Okay. Some certificates verify. In this case, what I did was I literally just extracted the CA certificate from my cluster and said, this is a trusted CA. So I told OpenSSL here, there's your trusted CA. Now verify for me whether this client cert is valid. And it came back and said, that client cert is okay. You trust the CA that generated it. If I take that out, it's a self-generated CA. So of course it's not trusted by anything in the world. But this is the kind of thing that OpenSSL throws out at you if you have a problem with your certificates. You probably will see that all the time if you're browsing to the dashboard or something on a Kubernetes cluster and your cluster certificate was self-generated. Firefox complains at you, Chrome complains at you. I think Chrome won't even let you go there anymore. It distrusts self-generated certificates so much that it doesn't even let the user override in some cases. Let's see. So working with a live server. So that's great if you have certificate files already on disk that you can just read. But what if you need to verify with a particular server whether it's valid or not? You can do that with openssl client. You tell it to connect to a server, and it connects to the server and says, no, that certificate is not valid. I don't trust the CA that issued that certificate. I'm unable to verify that. But then it'll give you the certificate chain anyway, so you can see what it is that it's having issues with. If you feed it the CA certificate with the CA file again, it'll tell you, yeah, that's fine. Some of the other basic tools, I don't have examples for these because any examples I did would basically just be man page examples, and you can go look at the man page for them. But there are some things to note. Dig, TCP dump, netcat, and SS, or some people just say systat. They are useful for debugging your network traffic and your network interfaces. You can break into a container and run a dig and say, well, okay, DNS resolution isn't working. Why isn't it working? You can actually recurse your way up the DNS chain and pinpoint where that is failing. You can do a TCP dump. You can say, well, okay, I know traffic is going out of this container. Is it coming into this container? No, it's not, or yes, it is. If it's coming in, maybe something else is happening to it. Netcat, you can test bandwidth between two systems, two containers, whatever. You can see if something is slowing you down that shouldn't be. And SS, systat, which is the new, instead of netstat, to look at what's listening on open ports, you should be using SS instead of netstat these days. And so that's one of the things that I wanted to note there was, some of these tools the traditional tools have been deprecated, like ifconfig. You should not be using ifconfig anymore, not even for old-style debugging of regular bare metal systems. You should be using IP adder show, IP route show, that kind of thing, the IP route 2 tool set. And netstat has been replaced by SS. The other thing is, be aware of dependencies of these things. A lot of the time, you can't just copy the binary and expect it to work. There's going to be libraries it depends on. In particular, anything that involves DNS is going to work differently in a muscle-based container that doesn't have the traditional libc in it. So if you're running Alpine and dig is acting funny, that may be why. It's not that it's broken, it just acts differently. It is very strictly within the spec for libc. So now we come to JQ. We've already seen that JQ can filter your JSON for you, but what can you do with it? Basic usage, you pipe some JSON content at it, you give it some flags, you give it a filter expression, and it spits output out the other end. Easy filters. The dot filter. You say JQ dot, and it doesn't filter it at all. Asterisk. Why did I put asterisk there? Because the JSON spec actually says that beyond a certain precision, you are not required to faithfully reproduce numbers. So if you feed something in that JQ recognizes as an integer that is of a higher precision than it can handle, it will smash it down to lower precision, and there is not a darn thing you can do about it. And yes, the bug has been filed, and the maintainer said it's allowed by the spec, so I'm not going to change it. You won't probably run into that too often. The one place that I've run into it a lot, though, is if you're piping output out of etcd, because an etcd node ID is a uint64, and that's a higher precision than the JSON spec handles. And so if you pipe etcd JSON cluster info into JQ, the node IDs that you get out are not the actual IDs of the nodes because of that precision issue. But you can see here what I did was I just took this long single line JSON expression, which is very hard to read, and I piped it through JQ dot, and JQ gave me this nice little key tree here. So you can see what's going on. I can do a little more than that. I can say dot key 2. And then what it says is, oh, he is just interested in this here. So it gives me just the value of key 2 in that tree. I can say, hey, there's an array there. I want the second item in that array. They're zero-based arrays. So if I say dot key 4 index 1, it gives me this, because that's the second item in the array. There are functions built into JSON. It's not all just hierarchy filters. You can see here I said select something based on containing something. And so what I end up with there is this long expression I basically took that same expression I had before, and I duplicated it and changed some of the values. And so if you go in there and you play with this in the slides after this talk, you'll actually see that what you would get there if you just ran it through JQ dot would be about twice this much output. And because of this select expression, it's zeroing in on 1/2 of that object. The other thing is, I could sit here and talk all day about JQ. There's a JQ cookbook and a JQ manual. You should definitely go read those, the cookbook especially. The other thing is, if you're having trouble with something and you feel like you're almost there but you can't quite get it, there's a Stack Overflow community around JQ. They do ask that if it's a problem with using JQ and not an actual bug, that you put it in Stack Overflow and tag it, rather than filing a GitHub issue. Scripting beyond one-liners, you can create a script file just like you can create a bash script file, and for most of the same reasons. It's more readable that way. It helps mitigate some quoting issues. One of the things you may notice if you go back and look at this example is I have single quotes around this whole filter expression. And that's because, if you don't put single quotes around it, sometimes your content contains like $signs and they try to get interpreted variables and shell meta characters, and it just becomes a big mess. So putting your JQ filter into a script file can help mitigate that. So here I just created a very simple script.jq that was essentially the exact same thing that I had here. So this one-liner JQ becomes call a script file, and I get the same output. But it's a little bit cleaner to read this than it is to try and make sense of it in a single one-liner on the command line after a pipe. Let's see, where are we on time? I think we've got time. Your bash prompt is actually an important debugging tool. It can help keep you out of trouble. So one of the things that we've all gotten used to is if you're running as root, your prompt changes to a hash mark from a $sign or whatever it is that you normally use. So a visual reminder of which cluster you're working in and what context you're working in can be useful. And so I actually put a little example here of what you could do in your bash profile. This is a command I just found out about a few months ago. You can define a prompt set command, and then it will actually create, you can put whatever you want in there. And then when you run that through your bash profile, when your bash profile gets sourced on login, now anytime I have kubeconfig set, I get this up there. It tells me, hey, you're in this Kate's context, admin at local. So that's kind of a warning to me. I could even put like colors and highlighting and bold and stuff in there if I wanted. I just did that as a real quick demo. Let's see, okay, we're doing good on time. Getting your tools in where you need them. So we have lots of tools in our toolbox now. How do we actually get them inside the containers to use them in some cases? If you've ever done this with Docker, you can easily plug one container into another container's network namespace with this --net equals container. You just give it the container ID. It's basically the same way as when you do --net equals host. And then what that allows you to do is, in this case, I just ran Fedora on the same container in the same network namespace as the container I started way back at the beginning of this talk. That's just outputting random data. And then, because it's a Fedora container, I don't have IP route yet. So I install that stuff. And now when I do IPA, I can actually see my container network interface there. So what if you're not using Docker containers? What if you're one of the fortunate people out there who's using something else? I don't want to bust on Docker too bad. They're so dominant that it makes me happy whenever I see anybody who said, well, we run Rocket, because I used to work at CoreOS. You can still get into that container. Because what you can do is, in this case, I'm saying, well, where is that container running? What node is it running on? So that's the node it's running on. I did get pods-oy, and it told me the node. Now I go on that node, and I say, OK, what's the process ID? Well, this is the process. This is the process ID. What can I do with that process ID? I can NS enter that process ID and say, put me in that process's namespace. And if I don't give it something to run, it just runs a shell. And so in this case, it puts me in a shell in that process namespace. And you can see I'm looking at the same container interface without needing to do a Docker attached to it. So if you're going to run a debug container like that, which one should you run? Anybody want to take a guess which container I recommend you run? Come on, somebody throw something up. Huh? Good guess. It's really up to you. I don't care which one you run. I want you to figure out which one you should run. And it needs to have all the tools you need in it. It could be a standard distro container. If you've ever used CoreOS's Toolbox utility on container Linux, all Toolbox does is download and extract the Fedora container and run it as a privileged container. And that way you can yum install all those tools, or actually I should say DNF install all those tools that CoreOS doesn't have to debug your CoreOS host. I remember I used to teach classes for them, and I taught a class once, and I had a guy in the front row, and he went, "Oh my God, that's awesome." Like he had no idea you could even do that. If you aren't building your own containers, I recommend that you do it occasionally. Don't just say, okay, we're going to use a distro container and let that be the end of the conversation. Because distro containers tend to be pretty large. And I want you to get a sense of, do we really need to be pulling in 600 megs of distro container every time we need to debug something? Maybe you only need, let's say, 100 megs or 50 megs. What should be in your debug container? All your standard system tools that you need to debug your host. And that includes potentially things like if you have weird networking gear, weird storage gear, whatever it is. Filtering and parsing tools, we already saw JQ. Anything else that you feel comfortable with, throw Perl in there if you like Perl. It's been a while since I did any of it myself, but yeah, throw it in there. Any tools specific to your apps. If you're running production apps, I hope you have debugging tools for them, management tools for them. Throw them in your containers, because at some point you're going to need them. Demos. This is always the fun part, right? So what I'm going to do is, I'm actually going to play you, because it's all command line based anyway, and there's really no reason to do it live, but I can if you really want to see it. This is something, so the story of this demo is, I was going to demonstrate using curl to access the Kubernetes API. And it wasn't working. I was roughing it out on Play with Kates. Hands up everybody who's used Play with Kates in here. Okay, I see a couple of you there. Yeah. So I was roughing it out on Play with Kates, and it wasn't working. And I was like, well, I extracted the certificate, and it's not going. What's going on? So that debugging session actually became the demo. So we begin where I was. I was sitting on the command line. I was rude. I mean, I should be able to do anything, right? I install openssl. You get to see me fumble around on the command line for a little bit. JQ. This is when I think everything's going to go great. I'm just going to do this. It's going to work. I'm going to copy and paste that into my slides, and we're going to be off and running. Okay, that I expected, because I didn't feed any certificate or token or anything in there. So the Kubernetes API server should tell me I'm unauthorized. So I said, okay, let's extract all the certificate info. This, by the way, KubeControl config view minify, extracts just the info about your current context from your kube config. Flatten preps it to be actually bundled up and transported somewhere else, so you can see it put client key data and all that stuff that it normally redacts in there. So if you really wanted to, you could sit here and copy all this, but this cluster is not going to exist 5 minutes after I finish, so don't waste your time. Okay, so pipe it through JSON. Okay, we've got it in the format that we can extract things with. Make sure that we have a directory to put things in. Double check that I didn't already have that. Something in there that I was going to overwrite. Okay, throw the base 64 encoded output there. There it is. Decode all that base 64 output. Now I have my certificates there, and I can use them. And so I said, okay, use my certificates. And it said, you're unauthorized. And I went, what? And I said, okay, is it a valid certificate? And openssl told me, yes, it's what it should be. It's been issued by who you think it's issued. It says that you are system masters and user admin. So what's going on? So I said, well, let's throw a curl-vv in there. And that's when I saw this. And I said, like, if you heard a weird sound about a week ago, it was my forehead slamming the table in my office repeatedly. Because I went, why? Why would you do that? Current versions of curl don't do this, by the way. Because I actually went to file the bug, and I said, well, let me reproduce on my Fedora laptop first. And it didn't do it. And I said, OK, obviously they got complaints, and they fixed it. It didn't, by the way, do that with this client key. It didn't do it with the CA certificate. It only did this weird thing with the client certificate. But at least it tells me what to do there. So I said, OK, let's do that. Now I get lots of output. And now I can start filtering that output down. And basically what I'm doing here is just progressively filtering it down till all I have is the name of the nodes. And you'll see that happen in just a second here. And there it is. So I finally got authorized to the API server, and I got my node names. Second demo, if I have time. I do have a little bit of time. Second demo is based on a scenario. So we have a cluster we've been managing for a while. And we've got an employee named Jim. Any Jims in here? Maybe a couple that don't want to raise their hands because they know I'm about to say something bad. We've got this employee, Jim, and he's been an admin on our cluster for a while. And Jim just kind of up and left under bad circumstances. And so we need to figure out exactly what we need to remove Jim from because we haven't been doing our management like we should. So how do we extract out from our cluster what cluster roles is Jim bound to? So we can do a get cluster role bindings -o JSON, and it throws this big blob of data at us. I don't want to sit here and read all this. I'm going to filter it down with JQ. And so you can see what I did there. If I can scroll back up a minute. Where did it go? Well, I did a basic filter there. We'll just take that as red. OK, so you can kind of see right there that I filtered it down and said, tell me, first of all of the cluster role bindings that have subjects, because a lot of them don't, where one of the subjects' names contains Jim. And it told me, it gave me a couple of data blobs. And then I can further filter it down and say, just give me the names of those cluster role bindings. And now I know where I need to pull Jim out of the system from before he does any damage. So with that, final thoughts. I always like to throw a few in there. Don't panic. That's the thing I always tell people. I know it always feels stressful when you're in there and something's gone wrong and somebody's looking at you and going, find out the answer, fix it, fix it, fix it, find out. Well, know your tools. If you know your tools and you know what's underneath your tools, you can keep that panic reaction down. We're not doing anything new here. Containers are just Linux. I think somebody actually has that on their sponsor booth. Containers are Linux. I saw a guy walking around with that t-shirt. I think it was a red hat. Thank you very much. This is a QR code that links directly to the slides. It's just all that it is the slide link. Anybody have any questions before we have to get out of here?